Good day, everyone. Today, I will be presenting the paper entitled Regression-Based Electric Load Forecasting Using Econometric Data. The authors are Virgilio Sosa III, Mr. Ray Baron, Earl De Vega, and yours truly, Michael Ernie Rodriguez. We are from Palawan State University in Palawan. For introduction, electricity plays an important part in modern society, and it is a basic necessity for us to function in our daily lives. The electricity demand has risen in the recent years, driven by urbanization, growth of population, and expansion of economic activities. This made electric load forecasting an important tool for energy planning. The capital city of Palawan, which is Puerto Princesa City, is a highly urbanized city that experiences rapid economic growth, which affects electricity consumption patterns. In electric load forecasting, previous researchers utilized different statistical and computational techniques such as time series analysis, regression modeling, and machine learning. There is a significant gap in the use of econometric data as predictive factors at the local or city level. These factors will be checked for correlation. These factors are the variables, which to attain good forecast results. Addressing this gap can provide more accurate load forecasts that capture the ever-changing economic landscape and growing population of Puerto Princesa City. The main objective of this study is to develop a regression-based forecasting model to predict the electric load of Puerto Princesa City. Specifically, this research aims to first analyze the variables that can be used in electric load forecasting of Puerto Princesa City. Second is to apply forecasting models to predict electric load demand. Third, evaluate the performance and accuracy of forecasting models developed. And number four is to forecast the energy consumption and the peak demand for the next 10 years of Puerto Princesa City. Significance of the study. The results of the study will provide insights and information on electric load forecasting, which uses an econometric-based approach that can enhance power infrastructure and policies. The findings can aid the city government, distribution utility, and energy planners in crafting important decisions regarding the generation, transmission, and distribution of electricity. This study supports the Sustainable Development Goal number 7 in ensuring access to affordable, reliable, sustainable, and modern energy for all. Next, we proceed to the methodology. For the conceptual framework, we have input, process, and output. For the input, we have the historical data. We have energy consumption, peak demand, and number of electricity consumers, which will be collected from Palawan Electric Cooperative, which is the distribution utility serving Puerto Princesa City. While the population can be is obtained from the city government of Puerto Princesa. Next, for the process, we have correlation analysis, regression analysis, and error analysis. This will be discussed on the next slides. And we have the output, is the forecasted electricity consumption and peak demand. Correlation analysis is helpful to examine the connection between the independent and dependent variables. The dependent variable considered in the study is the energy consumption. On the other hand, the independent variables are the population and the number of electricity consumers. The closeness of the two variables is measured by the correlation coefficient. Next is the regression, was used to model the electricity consumption of Puerto Princesa City using the 5-year data from 2015 to 2019, which was the basis for forecasting the city's electric load demand for the next 10 years. The equation for regression is shown below, and then to find the best fit line for the dependent variable, the regression calculates the coefficients that lead to the smallest overall error, the t-statistic of the model, and the associated p-value. For validation, error analysis was conducted. The coefficient of determination R squared and the adjusted R squared evaluate the regression model and determine the performance of the model. The values of R squared and adjusted R squared have a range of 0 to 1, where a value close to 1 indicates a better fit of the regression model. Next, the t-statistic specifies the significance of the independent variable to predict the dependent variable and has a usual value of greater than 2 or less than negative 2 for each variable. Then the p-value should have a value of less than 0.1, which indicates a significant regressor. Lastly, the mean average percentage error, or MAPE, is determined. If the value of the MAPE is less than 5%, this shows that the forecasting has an excellent accuracy. Next is the forecasting of energy consumption and peak demand. Based on the independent variables, the researchers created three models to forecast the energy consumption. After forecasting the energy consumption using regression, the researchers then determined the peak demand. And then the peak demand is readily available or related to demographic and economic factors and is not erratic. However, the load factor is difficult to forecast. So that's why to determine the peak demand, we use the average load factor from the years 2015 to 2019. Next, we proceed to the results and discussion. For the historical data collected, we have from the years 2015 to 2019. We have for energy consumption, which is Y, in kilowatt hours, number of consumers N, and population P. Then the correlation coefficient between energy consumption and the number of consumers is 0.9862, while the correlation coefficient between energy consumption and the population is 0.9968. This indicates that there is a strong, very strong positive linear relationship between the two variables. Next, for the regression analysis, we have the three models developed. So first is using the number of consumers. Next is using the population. While the third model uses number of consumers and the population as the independent variables. So models 1 and 2 passed uh, the analysis, while model number 3 failed due to the values of their t-stat and the field value. Since MAPE of model number 2 is 0.88%, we use this to determine uh, we use this to forecast the energy consumption and the peak demand of Puerto Princesa City. So the equation number 5 shown below shows the second model with the values of A and B as determined by the regression analysis. And then we have also calculated the load factor using this formula. So from the years 2015 to 2019, we have calculated the load factors and determined the average to be 64.12%. And then the results indicate a clear trend of increasing energy consumption and peak demand. The rising energy consumption and peak demand suggest that there is a need for more power infrastructure in the city. This can impact the design and capacity planning of the electrical grid to ensure reliability and avoid power outages. Current situation, so we have currently two electric substations with a total capacity of 55 MVA. First substation is rated at 2 by 25 MVA, located at Barangay Tinigiban, here at the city. And second substation is located at the north of the city, which rated at 5 MVA, located at Barangay Lukbuan. To prevent overloading the Tinigiban substation, the proposed 2 by 25 MVA substation at the Poblacion area with a 69 kV tie line should be a priority project of the distribution utility. Also, the 5 MVA substation, which will serve the southern barangays of the city, which is located at Barangay Montible, should be constructed to enhance reliability and power quality in the area. Now we proceed to the conclusions and recommendations. Conclusions, the correlation indicated a very strong positive linear relationship between the energy consumption and the number of consumers and between energy consumption and population. Model 2 predicted that the energy consumption will reach 475,882,429 kilowatt hours, and the peak demand will be 84,723 kilowatts by 2029. The error analysis shows that the R squared and the adjusted R squared have a value of 0.9936 and 0.9915 respectively, with a mean average percentage error or MAPE of 0.88%. This indicates that the model has a very good fit and has excellent accuracy. For the recommendations, we recommend to use other factors that are significant to energy consumption like the GDP and others. Conduct scenario analysis to understand the impact of various factors. Also utilize advanced modeling techniques to enhance the performance of the modeling techniques or forecasting models and increase the forecasting accuracy. And then construct new substations to prevent overloading the substation in Tinigiban. And the generation sector and transmission sector should also upgrade the existing facilities to prepare for the increase in energy consumption. That ends my presentation. Thank you for listening and have a good day.